Hello everyone. As you all know that myself I'm Gangotri. Today I'm going to explain the topic of compressed data structure for binary relation in practice. Agenda. Today, one of the main challenges of big data research is the processing of big time series data. Moreover, time data analysis is of considerable importance because previous trends are useful for predicting the future. Due to the considerable delay when the volume of the data decrease, the presence of redundancy and the initiate lack of time series structure, the traditional relational data models does not seem to be adequately able to analyze time data. Moreover, many traditional data structures do not support time operators, which results in an inefficient access to time data. Abstract. Binary relations are commonly used in computer science for modeling data. In addition to classical representation using matrices or lists, some compressed data structures have recently been proposed to represent binary relations in compact space, such as K2 tree and binary relation wavelets tree, BRWT. Knowing their storage needs, supported operations and time performances is key for enabling an appropriate choice of data representation given in a domain or application. Its data distribution and typical operations that they are computed over the data. In this work, we present an empirical comparison among several compressed representations for binary relations. We analyze their space usage and the speed of their operations using different synthetic and real data distributions. We include both neighborhood and set operations, also proposing algorithms for set operations for the BRWT, which were not presented before in the literature. Introduction. Let A and B two sets of objects. A binary relation R is defined as a subset of the Cartesian product, that is A cross B. Wherefore, each element that A, B belongs to R. We say that A is related to B and denoted this as A or B. In the areas of mathematics and computer science, binary relations constitute a fundamental conceptual and methodological tool used for representing properties or relationships among the objects in a simple and intelligent way. In computer science, binary relations can be modeled by using data structures such as graph, trees, inverted indices, or discrete grids. Binary relations have been traditionally stored using either adjacency matrices or adjacency list. However, and due to the growth and the size that the sets of binary relations concurrently generated are experiencing, for example, a graph of the old www, it is convenient to store these sets using compact data structure. The goal of doing so is to reduce the storage needs, either RAM or disk, but maintaining the capacity of processing the data directly in their compressed form. Reducing the storage size may have the advantages of diminishing, even removing the need for I/O operations, that are input and output operations. When deciding which compact data structure to choose for representing the binary relations in the context of given domain or application, it is very convenient to know in advance the adequacy of the available data structure. In terms of storage needs, supported operations, and time performances, the decision can also consider the frequency of each kind of operation. For example, one application might make an intensive use of union and intersection operations, but rarely researches for predecessor neighbors and performs range neighborhood queries. Compressed adjacents list. A very navy And generally, space-consuming representations of a binary relation is an adjacency list. Although a valid representation is not suitable if the relation is big and does not fit into main memory. To avoid this problem, the adjacency list can be compressed. These techniques can be applied to compress any input. The authors have already used them to compress binary relations using their own implementations. We must note, however, that these are not compact data structures. They are only compression schemes, and the list must be decompressed before they can be used to effectively perform the requested operation on the uncompressed data. Literature review. The comparison we performed consider for all the data structure the following operations, that are neighborhood queries is related, successor, predecessors, and range neighborhood. Set operations, union, intersection, differences, and systematic differences, that is symmetric. The work described here required the coding of all the algorithms, both neighborhood and set operations for BRWT as well as neighborhood operations for K2 tree, and compressed adjacency list using QMX and RICE runs for the remaining algorithm. The following table represents the average size in bytes for the different data sets. Our standard implementation using 32 bits integer, so it is used as a base number. However, in order to represent a relation for 1 million nodes, only 20 bits suffix. Thus, we also show the size theoretically needed to represent this relationship. Obtained by the K2 tree variants, which benefit for distribution of small numbers of one that are clustered as for the QMX and RICE runs. Their behavior is worse because they are based on run length compression and having a smaller runs of ones produce worse compress ratio. Architectural model. This is methodology. Considering the compressed data structures, we can see that standard K2 trees obtain a better result than the plain adjacency list using 20 bits for those clustered distributions. And the value 1 corresponds to the shortest time for the operation on a distribution. Result. We have found that there is no clear winner. No data structure is better than the rest of all cases. All of them have some advantages and disadvantages depending on the several factors. We have considered the storage size and response time as a basic measurement. Conclusion. We have conducted several experiments to compare the behavior of several data structures used to store binary relation. We have considered their three compact data structures K2 tree, K2 tree, and BRWT, and two encoders or compressors QMX and RICE runs. For the compact data structure, we used the algorithms for K2 trees and K2 tree developed, but the algorithms to set operation over BRWT are presented here for the first time, thus extending the functionality of this data structure. Thank you.